Welcome to the interview. I've heard about your Mario reinforcement learning project, that you are training AI on a physical console setup. Walk me through it. What makes this different from the usual emulator-based stuff?
Thank you for having me. It's a full-stack reinforcement learning system for Super Mario Bros., the All-Stars version for SNES. No usage of GIM. It's a real Retron 5 console with Arduino controlling inputs and video capture for observations.
Hardware integration sounds tricky. How do you manage the messy real-world inputs? Video noise and latency can kill an RL agent.
Carefully, I divided the problem into targetable areas. When a human plays the game, we look at certain game elements for different purposes. The OCR component keeps track of score, keeping in mind that anything that the game character does that earns points will also earn reward. The object detection component tracks if Mario is dead, small, super, or fire mode, and can apply reward/penalties based on state change. I use structured error handling, including retries if Mario's not detected, policy management to prevent stuck conditions, and other safeguards to protect against bad values to ensure reliable runs. The policy watches where Mario is located and encourages certain actions during the random selection process based if character center is centered on a pipe. If Mario ducks, then it gets a small reward, but only for 3 attempts. The policy will track the attempts, and after the 3rd attempt start applying a penalty. I coined the term as pipe obsession. This highlighted one of the flaws with RL models is the short-term gratification impulse needs to be tempered.
Impressive breakdown. But RL on physical setup, that's uncharted. How's the policy held up? Collapse is a killer in these sparse reward opportunistic games.
I kept it simple. I forced Grok to figure it out. As a program manager, I work with developers to build products, so portions of this are in that line of thought. Working with my junior developer, aka Grok, I had it build a proximal policy optimization with actor-critic convolutional neural network. Anti-collapse was built in with cool back-libeler targets, entropy decay, and variance checks adding noise if too low. Actions are high-level, like run right high jump, filtered by state. Also incorporated a replay method that mixes top episodes for stability. There remain some concerns when dealing with a short episode. There has to be enough something for it to learn, so the code will determine if the episode was sufficient and add noise to prevent collapse.
And results? Has it actually beaten a level, or is this still theory?
Cleared 1-1 multiple times, albeit sloppy, but real cartridge, no state cheats. It is not at speedrun levels, but it is still a world first, at least as far as I know. I do not claim to be a great ML scientist, but know enough that when dealing with the physical layer, each episode and each step within requires stronger enforcement than when you can run multiple instances. In short, I used reward/penalty values that would be considered extreme. A negative 50 mil death penalty, for example, creates a paranoia effect within the agent. It learns that the enemies are pain, so it avoids the pain. Through random move selection, it will jump on the enemy, which gives it 100 points to the score. I used a score multiplier so that 100 points is a reward of 10,000.
A physical clear. Edge of the seat stuff. Many companies are pushing for real-world AI. How does this align with that?
Fits perfect. This project's about elemental truths. No sim shortcuts, just raw perception and control. My experience in software development, cybersecurity, and program management was instrumental in creating and successfully completing this project. I must admit that I leveraged Grok extensively. The total project consists of over 5,000 lines in Python across 3 different projects. The TROCR and OD models are not off the shelf and required careful use of the daily Grok expert limit.
Wait. So, you're telling me that you built this whole thing based on Grok prompts?
I would say that a fair assessment is that I wore my program manager hat and leveraged Grok as a junior developer with severe oversight.
Ouch, Grok really does have all these advanced models. And when it comes to code creation, some of them have actually been rated fairly well. But let me ask, have you thought about trying other services that are more directly focused on software development? Sometimes those can make a big difference.
I didn't use the more advanced versions due to costs. Instead, this was completed with the 10 questions per 12-hour limit. Financial investment is non-existent. So this was effectively created at no cost other than labor, and a part of my remaining sanity.
Sold. What's the biggest lesson from turning theory to that first clear?
While I'm glad that I was able to successfully complete the level, I can see there is some work to complete the entire game or to proceed on any others. That being said, there are lessons learned from each portion.
Well, those are fair points. There are plenty who say they can accomplish tasks, only a few truly can reach the stars. But enough of the suspense, show me the clear.
Certainly. Then let us begin.